crazy world. You've arrived at, that's a pretty crazy idea. And me, I'm John. I spent a little while thinking about whether to change the EEPROM or fix my car's original computer. I decided to try the latter first, even though I'm pretty sure I've come very close to figuring out the EEPROM location for a 2007 Honda Fit. In another video, I'll be explaining the techniques I use which may be helpful to you for figuring out the EEPROM in your car. That's of course if you can't find it on the internet. The first thing to note was that since my part was not completely fried and only acts up when it's hot, it makes finding the fault that much harder, especially if you don't have all kinds of computer test equipment. On top of that, I have never worked on a printed circuit board before. But look at all the cool new stuff I had to buy. New soldering iron, new hot gun. Okay, enough frivolity. Let's get on with it. So the plan is 1. Change the first chip. 2. Reinstall the computer. 3. Wipe the codes. 4. Do a complete test drive. 5. Check if the codes came back. 6. If the first chip did not solve it, then change to chip number 2 and go through the same sequence again. It's a processor, and we go to step 7. Change the EEPROM. If you're asking, how did I figure out which chips on the computer were the ones to change? Well, I traced them back with the continuity tester from the ground pin numbers on the electrical diagram to the transistors, and I did it like this. Okay, just a quick video of how I figured out it was this chip and this chip that I needed. Okay, this is the wiring diagram, and here's the ground, and here's the ground, and these are all feeding into this ground here, and they're coming off of here. All these sensors are pushing over to here and over to here. I've already checked this and this pin block here, and this is the one that heads over to the computer, and that's terminal A3, and then you have A8 and A9 there, which just come straight over here or come up here into all this circuitry here. So that's how I know that these are all feeding into these particular terminals. And so the fault is going to be somewhere where on one of the transistors that come into contact with this. Okay, so how do we know which section it's on? If you look really closely, you can see an A. I don't know if they'll be able to pick this up, but there's an A right there. And then when you turn it to the back side, there is a number here. And I don't have my glasses on. Okay. There's number 9 there, 21 there, 31 there. And so this from here, oh, there's a 1 there, and a 10 there, and a 22 there. So this is the A block here, and it goes from 1 to 9, 10 to 21, and 22 to 31. And I happen to know that I need
2, 3, 8 and 9. And when you look at it the other side, you know that this is now 8 and 9 on the outside here, and 2 and 3 are these two, the ones with the separation. And that's what you have to deal with. Okay. And yeah, I'm going to try for these two and these two, which relate to this one and this one, and this one and this one. And what I found was these two. So if I go here, you hear it there. This one you don't hear anywhere, and I don't know why, but I just went around looking for a tone. Pretty well much. Oh, so it heads up all the way up to there. Are you still in focus here? Yeah. So I just went around scrolling through all the little pins just to see where the sounds were coming from. And, well, we've got something there too, eh? Okay. Got to make sure you get the right one, because if you're not on the right one, you can be going into a different circuit. So this is 9. Now, let's just try this over here. There's nothing on this guy. So if we come over here, I believe it should light up now. Oh, there. Yeah, there we go. It's a little easier if you actually put these on yeah, that's what I found the first time was this chip and this chip. Were the first to actually get three. Now I happen to know that this one is the AC DC converter, and like I said before, because it sits flat against the wall here and it's got even a tie down strap, it's probably got this is a heat sink, so it's pretty warm, this one. So although none of them look fried, none of the capacitors look damaged, my guess is it's probably this chip that's causing the problem, but we will not know until we change them one at a time and go from there.
Ultimately, finding it went into this chip here, and this chip here, I'll be changing this chip first. As to why, I think it is this chip because it has 3 features. It converts the grounding circuit AC electrics in the computer to the DC side of the car. It must also obviously get very hot since it is held in real tight against the wall. So I'm saying that that's going to be the heat sink, and I guess changing from AC to DC gets pretty hot. Most transformers do. So, okay, but the real reason that I'm changing this one first is because it's a whole lot simpler to change this one than this one. Now, what led me to this was how the car acted while being driven. It drove fine for 20 to 30 minutes, which was long after the engine was up to temperature. Only then would it start to act up. I suspect the computer was working okay when it was cold and electrically discharged, but when it got warmed up, something started to overload inside the computer and did not let the neutral energy go back into the car. The voltage in the computer circuitry would build and show a high voltage, etc., from multiple sensors, leaving my code reader with multiple codes while at the same time reading the same fault. Expecting my problem would lie somewhere where all the circuits intersected, i.e. a wiring short or computer problem. It was also only from the engine management wire harness that the faults were emanating from, not the fuel, safety or instrument gauges that are on other wire harnesses. By changing chips one at a time and wiping the codes, it will tell me if I fixed the problem. Okay, let's get to replacing the first chip.
So in case you're wondering why I've ended up buying 2 of this one and 2 of that one, it's for one reason. I had to buy these. They're $2 to $3 a piece. The shipping is $20, $24, somewhere around there. And I had to buy them from 2 places. This one came from China and this one came from Canada. So, just in case one doesn't work for $2-3, I thought, well, I'll just buy a second one just in case I bugger one up, and I got a second shot at it all. Okay, let's start this again. I ended up with only one glove. That's all that's left. These are the 3 little spots I need to do. That's a bit too much flux. Let's just take some of that away. And there we go. And let's turn. I gotta heat it up first. Low. And 20. Okay. I'll heat it up for a few minutes here so we don't damage the board. Now this is the first time I've ever done this, so it should be interesting. The reason I'm doing this one first partly is because this one's going to be a little bit tougher to do than this one, I figure. So preheat the board, put on flux, pull off transistor. They make it sound so simple. Lick off solder. I'm just doing what they show on the internet, on YouTube. So, good luck to me, I would say. That's what I think. It takes a few minutes to heat up the board, apparently. You just need it heated in the localized area, I'm guessing. Okay. Now that I'm going a little bit higher, I'm going to add a little bit more flux just to make sure I'm... There we go. And then we'll keep going low. Can't tell with this one just how hot it is. It's plenty hot. Okay, so yesterday I had a totally rookie thing going on. I had it set on Fahrenheit, and I thought 400 on Fahrenheit would melt the solder, and that's like whatever, 200 degrees Celsius, and you need 400 degrees Celsius. So let's see how she does. Could use some glasses here. Okay. Machine's still not well, obviously whatever the heat is, it's not getting over to the... Let's add a little bit of flux maybe. Okay. Wow. Something's not working here. Yeah, barely melts solder here. I think something's wrong with the soldering iron, that's what I think. So it seems to be melting this solder now, so then that is a good sign. It'll warm it up. There we go. Easy enough. Now let's just try and hopefully it melts these guys. You know, I think I better do it differently here. I think what I've got to do is cut it off here and then pull one pin out at a time. Because doing all 3 pins and getting them melted is impossible. Okay, so the only way to do this, oh yeah, thank you, is to snip this guy off so that I end up with 3 little individual pins. Oh. Defeated by the strength of little pins. Wonderful. Ah. Oh, there we go. So now all I got is to pull these 3 little pins out. That should be a lot easier than try to unsolder 3 of them all at once. And that's what I gotta make with the new one. Okay, back in business again. Maybe. Yes, maybe. One. This 1, 2. Even though the temperature's saying it's got the full amount, but maybe it's not.
Maybe they gotta turn it up harder.
I turned it up. It's actually higher than it's supposed to be.
No, yeah.
Yeah. Okay, gotta bend the pins so that they look like this. So make sure you got it turned around the right way around. Okay. Nice and easy to bend. Okay. Then that's one bend. I guess I might have to chop the top off of that. And then we gotta get it so that they're bent in line with this. Oh, that's handy. The bend is right where the change in the dimension is. So that makes it real handy for me to know where to do it. Grab it there. Push them down. There we go. That was the easy part.
Did you get it out, the third one?
No, I didn't get that last pin out. No, I don't know whether the iron just loses some of its heat, and it has to be shut off and let cool down and then heat it up again. He took out the first two, not too bad. But so now, what I gotta do? So now I'm just bending the pins to what they should be, and I just got to figure out how long they have to be now.
Yeah.
Oh, that's right. I was gonna. I'm gonna leave my pins long and then trim them when I've got them through.
That sounds like a good idea, John.
Then I got something to hold it with. Hopefully I get the right height. I forgot to measure the height. Oh, I guess I got the other board there. I can measure the height on. Okay. Back to this one. Turn it back on. 790. I'm using a little higher heat because this one just does not want to do anything that it's supposed to do. The chip is ready. Okay, let's see if she'll come free this time. Come on, melt on me. Can't believe how hard this stuff is to melt, this iron.
Yeah, right.
Finally.
Did it come out?
Yeah.
Excellent.
I just got to clean it all up.
And then you can put in the new guy?
Yeah.
Oh, very good, John.
Okay. There. Okay. Okay. Side. Okay, let's get a cleaning one. Okay. I just took off all the flux with some alcohol, a swab, dried it off with another swab, and you got to get rid of all the swab hair by brushing it off. Oops, there's a piece there. Okay. So the next trick is to put the new one in. Something like that. So I'm just preheating the board. This takes a few minutes. Works pretty good though. It's not too noisy at least.
Yeah.
Okay, let's see about putting some paste on there. Come on. There we go. Should be plenty. Let's see if we can get it to draw down into there. Do its thing. A little bit higher. Look at that. It's working just sort of properly. this one. And there we go. That's a beautiful thing.
Yeah? I'm waiting for something new, John.
Oh, that looks like it's worked. Maybe just a little bit of flux over in this middle part here. Just clean it up. And clean up a little bit of problem. Ooh, came through on the other side nicely. So that actually worked pretty good. The only thing I'm not sure about is right there. Yeah, a little bit off, maybe. Ooh, very hot. Okay. I think that's that part done. Like, oops. Where did I put the other part? I think you can go on now. Okay. So we got the chip in. It looks fairly good. Don't know how well you can see it, but the soldering turned out quite nice. But on this side, and I don't know what it was, but there was a gummy-like material, and I had to scrape it out with my edge of my pliers, because I did use the alcohol and Q-tips and the brush on it, and it still left this residue in here. It was too really hard to get into with even with the Q-tips. So now what's left is to trim these 3 little stubs because they're too long. So we're just going to do that now. Maybe I kind of need my glasses on for this. Okay. 1, 2, 3. So that's that. So this has all been cleaned up nicely. And hopefully it's cleaned up good enough that it can go back into the box. Okay, just stick all these back in. think I'll be happy even if it just fires up, to be quite honest. Because I don't know how much damage I did doing this. Okay. Let's put this guy in and pull her back.
John, let's just wait till the end of the week and maybe I could have someone to relocate it.
Yeah. This. Yeah, that's like this. There we go. The easy part. Putting the lid on. Yo! Starting to feel good about this.
Maybe after it runs and warms up, maybe we could just go around the block or something.
Yeah, I don't want to go that far. I don't want to get into Newton, that's for sure.
No.
Until I confirm that all the codes are dead and gone. Okay. Computer is back together.
Wow, if you stuck it out this long, you get to hear the rest of the story. So anyone who's already left, too bad and so sad. I plan on doing this on all my videos to put a vital bit of information near the end. The question you need to consider is, why did your computer fry? My problem almost for certain did not start in the computer, but in the engine bay with the ground straps, which over time corroded and stopped allowing the neutral power to discharge back into the battery. This allowed energy to back up into the computer module, which caused the computer to overheat and damage the computer circuitry. So if you just replace the computer and do not deal with all the engine ground straps, your new computer will fry, just as the old one did, but in a shorter time frame. If you got the computer car, you also need to tighten up the negative terminal properly all the time and not just sit it on the pole like we did in the old days when it was just not that critical. I'm making separate videos showing how bad the engine earth straps were on the fit and flashing lights and all. Stay tuned. So, if you do not deal with cleaning and securing all the engine earth straps along with your computer, it will likely fry something in the little box a second time. And won't that make you happy? You might ask yourself, why would you do all this when your local Honda dealer will reflash the new computer for $250? Don't. But would they fix all the engine earth straps for you at the same time? Gotta wonder how many mechanics would realize that what was the cause of the problem in the first place and fix them at the same time. Or would the new computer act up fast enough to show up the downstream problems before you collect the car? That's it. Hope you got something useful from this video.
Hey, here goes nothing. Let's turn it off. It's idling pretty rough. Well, that's looking a bunch better. It is running really rough, and that number 4 cylinder, I'm not sure what that is. So let's try the next one. Pending. Misfire in number 4 cylinder. All the other ones are gone. What a... And all of these, I'm not sure what they are just right now. But this one was read before, the KTR. I know one of them is the... for the... what do you call it? The oxygen sensor. And I know there's no... There is an oxygen sensor, but there's no... the previous owner removed all the stuff from the catalytic converter, so I know the oxygen sensor there is going to always show. So misfire in number 4 cylinder, that's it. Maybe I have the wire pulled off. Let's go check it.